Hello and welcome to this bonus video where we're going to create a range mapping group or range mapping node for Cycles 4D. So first off, we're going to need some input to range map, so some values to range map. And a good way of getting some variable ranges is with an emitter. And we could use their color, their radius, all sorts of different inputs to range map. So let's add an emitter. And we're going to look at it from top down mostly. And we're going to look at it almost like a plane. So let's shrink it the height down. If I go to this object tab, you'll see I've made the height 0. Make the width 200, and I'm going to make it go left to right. So let's go to the emitter plane, change it to X positive. Let's just press play. And stop it at frame 90. Now, I didn't just magically catch it there. I actually have my play mode set to simple. If you have it on cycle, it'll just keep repeating the timeline. I like to have it on simple, especially when dealing with particles, because you might run a simulation and play to the end, and then all of a sudden it jumps back to the beginning, and you have to run it all again. So I've got it on simple mode. There we go. It's stopped. Probably not enough particles to kind of create a thick sheet of them. So let's go for 5,000 to start with. I don't need too many. It's just to demonstrate some things. Okay, that's perfect. I'm going to compare it to some geometry as well. But we'll do that later, actually. I'll add the plane in later. So for now, I just want to have some input values. So what I could do is I could do varying radii. So let's go for a radius of 2. In fact, let's do a huge variation. Or let's do 2.5 and then 2.5. So now our particle radius is going to be from 0 to 5. Now, if I change my display mode to circles, we'll have a bunch of variation in the radius. And you can see that if I zoom in, you can see there's tiny ones as well. Now they're overlapping a little bit, so maybe we can get away with fewer particles, or maybe I'll just drop down our radius. So maybe we go down to, let's say, I'll just go for a radius of 1 and a variation of 0.5. So that's going to be, oh no, actually, so let's do radius of 1 and 1. That means we're going to get 0 to 2 maximum range. There we go. I think that's going to look nice. And now I'm going to actually also use color as an input as well. So I'm going to change their color. So display, use gradient parameter, and then I'm going to change this to a black and white gradient because I want the input for this particular one to be 0 to 1 in value. So that's, if you look at this value here, that's at 0%. And if you look at the white one, it's at 100%. And behind the scenes, that's seen as a 0 to 1 float value. Don't worry about that too much again, but let me just play the timeline and it should just change over age. So let's jump into a cycles interface, and I've already got that running. Choose my devices, no problem. Now nothing's showing at the moment because I don't have any materials or tags on our emitter here, or any lights in the scene even. So I'm going to create a cycles material, and I'm actually just going to use one of our presets, which is here. And you can see X-Particles color emission. So what this will do when I add this to the emitter, it's just going to take the color from the emitter and pass it into cycles. Just to prove that, let's load a preset gradient in, go for full colors, press play, and you can see there it's translating that. But I don't want a multicolored gradient. I want to go back, so I'm just going to undo that, play to our 90th frame, and then this is where we're going to start. This is where we're going to spend most of our time to create the range mapper. Okay, so what we have here is we have a particle info node bringing in the color, which we know is a 0 to 1 value. And then that's going into an emission node, which is set to strength 1, and then that's going into the output. Perfect. Right, so how do we justify a range mapping node, and why is it useful in this scenario? So let's just, let's use a particular scenario. I'm going to add a ramp. So let's add a color ramp. And this is a very common workflow you'll probably have seen from other tutorials. And what this can do is this can remap our color values. So let's say, let's go for the heat one. It's a good one to see clearly if your gradient's being remapped well. So that looks perfect. That's taken out these colors and mapped them to the black value, and the last ones here are mapped to the white value. Now I could just change the gradient mode to a gradient random. And if you look in the viewport, we've got a full range of black and white colors. Doesn't really matter on what they are they are, you know, it's not based on their radius or anything, which is what we're coming on to in a second. And that's great. But we don't want that. We want to go back to our gradient parameter, and that's set to age. Press play. Just let it go to the end again. And where this becomes an issue is that what if I want to change where these values are? So say I want to take a slice of this and only have the gradient in this section. It's a little tricky. Now what we could do is we could take a color ramp, and that's connected the alpha up. That's always one to watch out for. So I've reconnected that there. Now it's slightly shifted. If I mute this node, you'll see that's shifted. What that's doing is that's actually, this gradient in cycles is a smooth gradient, and really I want a linear gradient. So that's where you want to watch out for that. And now our input is linear and our gradient here is smooth. That's not a problem, and it looks nice. Okay, so what we could do is we could clamp it by dragging our black value here and our white value in here, and you can see now our ramp is going from this point to this point. However, it's just not that accurate, so we don't know exactly those values. So this might be a specific age or something like that, but it's difficult to know exactly where those values are. So a range mapping node would allow us to set exactly the points at which we want to map this gradient to. So the age, we won't deal with age for this, but I just wanted to use that as an example. We'll probably work more with the radius. So here's another problem, is that if I grab the radius and pump that into there, we're only seeing blue. Now that's not because there's not a wide range of gradients. It's because the radius values are so low, they're below 1. So they're like 0, because it's in meters. This radius value for cycles is seen in meters. So it's 0.015 or 0.03, I think we had it at. That is the maximum value. So obviously we'd need to shrink this gradient, and I can kind of do that by, if I really tightly move that down this end of the gradient. Oops, I shouldn't add a new knot. So I just want to add that there. So there we go, and you can see some of it's included, but that's even that is just in the blue range, so I'd have to shrink it right down here. And you can see this becomes incredibly impossible to manage. So that's where the range mapping node is going to help us no end. So let's start actually creating our range mapping node and seeing what we actually need in terms of inputs and outputs. Let me reset this gradient to our heat one, and that's going to be a good way to diagnose things. And let's zoom out. So we're framing it up nicely, and let's start adding some groups and math nodes. And then knowing which of these nodes or groups we need to add first is quite important as well. So if we bring on that equation, which is our range mapping equation, and you can see here we have the output, which is going to be our resulting mapped values or range mapped values. And we have here an input value. That's going to be our radius or our color, you know, our 0 to 1 value perhaps, or it could be any number range you can think of. And here we have input minimum, input maximum, output minimum, and output maximum. So our group is going to need these on them to be able to control them. So first of all, the input, that's not a user input value. That actually, or sorry, like a slider or anything, that's actually going to be our whatever is fed into it. So we could feed user info into it, but it's not particularly useful that way. So I'm going to add, first of all, I'm going to add a math node, and I'm just going to start by doing one of these operations. And the reason I do that is that then from that, you can start creating the group. So I'm going to grab a math node, and I could just drag it in between here. And so this is remember, this radius value currently, or actually let's go for color. That is our input value. And you can see already that's having an effect because I've divided, I've added 0.5 to the input color. So if I set it onto that color, you'll see we get like a much faded gradient essentially, but that's not the operation we want to do. We actually want to subtract. So maths obviously has an order of operations. If you don't know about that, don't worry too much, but basically there's a term, if you say PEDMAS, PED, MAS, and that's like the order of operations. Now P is parentheses, E is exponent, so that's like squaring, powers 2 and all that stuff. And then it comes into the division and multiplication. Now they're on an equal footing, and so that brings us to M, and then AS is obviously addition and subtraction. Now, obviously we want to do the parentheses stuff first. So we know that this inside, we've got sort of a multiple nested parentheses here, so we need to do this one first. So all I need to do is I need to take our input, and then I need to take away from that the input minimum value. So what I've done here is I've added this math node. I'm going to change it to subtract. And now this value is actually going to be our input minimum. And it's a bit hard to see that right now, but we'll deal with that later. Let's set that. I'm going to set that to 0. And then you'll see that we've actually subtracted nothing from it. So therefore our gradient doesn't change at all. Now we need to do this other one here. So this input maximum with the input minimum. And this is where you're going to start realizing that throwing it into a group early on is actually going to be very useful. So I'm just going to, because it's a subtraction, I'm just going to duplicate that node by holding Control or Command whilst I'm dragging. And then I can say, let's take input minimum, input maximum, and subtract them. Now, we don't actually have any values attached here, so it's actually kind of useless. I could create like an absolute, I could bring a value node in here. Let's do that just to demonstrate. So I could say, here's our value. And if I rename that perhaps to input min, and then I just attach that to the lower value, and then I duplicated that and put that into the maximum value, rename that one. You can see this gets quite clumsy straight away, but it does mean that I can drive my minimum value twice. You know, I can have that like that, but this is not tidy and I don't like this. So what we're going to do is we're actually going to group these nodes. So if I select both of them and I hold Alt G, you'll see that I create a node group, and it's detached it. But if I go into it, you'll see that our nodes are inside here. So what I'm going to do is I'm going to take the input value like we had before, make sure it's connected, and you'll see it creates a node for us. It creates a port for us. And you can see it's just called value 1. Now I want to call that, I'm going to call it input value. So it's the input value. So input value. Now you see down here, the reason I'm calling it input value, I could just call it input. This input, when you see a white port like this, if I drag anything into that, it will automatically create a new port for us to utilize, which is great. But obviously the naming there, you want to avoid collisions with it. Only for user readability. It's not a problem if you did name it input. So I'm calling it input value. And then remember we need to, what do we need to do with that input? We need to subtract the input minimum value. So let's do that. Let's add another port. And you see here's my value here. And I right click here and I can rename the port and I can say input max. So that's now our input max. And now we can use that input max in, I've named it incorrectly. It should be input minimum, shouldn't it? Sorry about that. So input min, that would have caught me out pretty quickly, so it's fine. So here we've got this first part of our equation. We've got the input being subtracted by the input minimum. Correct. Now our second equation is input maximum subtracted by input minimum. So let's just create a new port, which is the top one. So that's our subtracted from. So drag it into the input port and you see it creates a new one. And I go right click, rename port, input max. Perfect. I'm going to create that. I'm going to change that value to, and if I just, you can see over here, I can click it in here. I could just do 0 to 1. And now we're going to subtract our minimum. So that's just this part of the equation. So we've done input going into here, being subtracted by input minimum, correct. Our next one is input maximum. That's this one here. It's going into the top port of the subtract maths node, and then that's subtracted by the min. Great. Okay, so that's sort of also an introduction into how it creates the ports. Now, what are we doing with those inside this particular parentheses? We are actually dividing them. So we need another maths node. Bring in our maths node. Let's change it to divide. And let's plug that in there. And plug that in there. Because we are dividing the result of this first subtraction in the parentheses here with this subtraction here. Excellent. Next up, we're going to do the next parentheses. So, because we've dealt with this parentheses, well, there's multiple ones. So there's 1, 2, 3, and then now we're doing with the next one because we're going left to right as well. If you know which parentheses to do first, you do left to right, and that's how I'm doing it here. Okay, so we've got our input minimum maximum setup. This one here is a similar setup, but it's a subtraction again. So if I just grab my maths node, do a subtract, and then I take, let's put this on this level, and I'll explain about how to lay out your nodes and things like that in a second. But we need two new values. So we need our input maximum. And actually, first of all, I'm going to create my input minimum because otherwise I'd have to reorder these nodes. If you look at here, we can actually move the ports. In fact, let's do that. So I just need two new values to input into this subtract, one called output max, one called output min. So I just drag into there and I just drag into there. Now the top value, I need to be output maximum. So I just go right click, rename, output max. Oops. There we go. And then I'll jump into the next one, right click, rename, output min. Now that I could leave them like that, that's not a problem, but I want them to balance out with the input minimum and maximums as well. And having maximum before minimum just doesn't seem right. So what I can do is I can right click this bottom port and I can just click move port up. And you see it switches them around and that minimum is now above the maximum. And I just like that for it's just nicer for the user to work with. So I'm going to set some, these two, I'm going to actually set their minimum maximum. If I set it to 100, just something different other than the, actually if I leave it at 1, it'll just mean that it's default, and that is, those values are, nothing actually happens to our range because the range is the same. So, and we'll talk more about that later. So why have I put the subtract here? Well, the subtraction of these two values then gets multiplied by the result of this parentheses. So the white parentheses, which was our division. So here's our division. Take our maths operator out. Let's grab another node and let's do multiply. And then we take the result of this parentheses and multiply it with that one. And that's all we need to do. And obviously the order doesn't matter on the ports for this one. And that's now given us so that's got us to our multiplication. So we've done our parentheses, multiplication, and now we can do our addition and subtraction. And that's the last thing we're going to do is an addition of the output minimum. So grab the maths node. And you can see once you've created these, you've got all of these here. We know where to input these values. So I'm going to take the result of our multiply, which is here, and I'm going to add our output minimum to that. And then this is where we need to output this value. So I just drag it into output, and you can see that creates a new port called value. I'm going to change it from value to, let's call it mapped value. So that's our new range mapped value. Okay, so now we need to test this out. So let's jump out of our node group. Now we can just hit U, which will go up. Or we could have gone here and clicked on this arrow, which will throw us up into the main node interface. Now you can see as soon as I pick this up, it's going to try and attach it. And actually, that's what we want it to do. But sometimes you want to be a bit careful. You'll end up accidentally attaching things that you don't want to, but that's perfect for us right now. I'm also going to rename our group, and I'm going to call it range mapping group. There we go. And we could change the color. Now, since this is a maths operation, and if I bring a maths node in here, I actually like to, if I create preset groups, it's obvious that it's a group from these icons here, but I like to actually match it to a, depending on what kind of operation it's doing. If it's like an info operation, I might make it the green color, but I might copy, I want to use this color. So change node color is what we were looking for there. And I'm just going to select the color picker and grab that color. Press OK. Perfect. So now we've actually got our node group. And remember, our inputs are already 0 to 1 anyway. Now let's just change some of these values and see what happens. So if I go to my node settings here, I change that to 10. Now, around about what's happening here is our range is being changed from 0 to 1 to 0 to 10. And our color ramp is ramping those 0 to 1 values. So it's actually 10% here. It's basically there. So I could do that the other way around. I could say the input maximum is 10. So the color, even though it's 0 to 1 in real values, I've changed it to 0 to 10, which means that our ramp, our ramp is only sliced from this tiny area here. Okay. Now this will make more sense when I use a different node, which is the whole purpose of why I was doing this in the first place. But let's use it to fix that problem that we had with our radii. And before I do that, actually, one more thing you can do is you can do things like you can hide the sockets if these are unused, and by unused it means any of the ones that don't have any inputs attached to them. It would actually hide them. So you can unhide and hide them. So these are classed as used because they have a connection. If I actually add a port, so if I add an input, just make it a color input, that doesn't matter really what it is. And I go back up to our group and I right click it and I go hide unused sockets. And you see there, it actually hid our color socket. It also hid our input and output. So it's actually now kind of in its final state. Although I want to unhide, I want to remove that port. So I'm going to right click it and remove it. Right click, hide unused sockets. And there we go. So you see now we have no additional sockets. So if we drag something in, we can't accidentally create a new port, and it's sort of protected. You can actually protect the groups as well. You can actually lock them. So if you go in here, you can see this thing here. You can actually do a password to lock it. We don't need to do that for this particular group. We don't need to protect this. This is quite a simple maths equation. I don't think anyone's going to be stealing this one and making money off it. So here we go. Let's use this as the purpose that we created it. And so if we get the radius and pump that in there, and if you recall, our radii were from, let's have a look at our emitter, emission tab. So our radius is from 0 to 2. And in cycles, it's going to interpret, it's going to use meters as its, or metric as its value. So the meters are, we need to change our our inputs minimum and maximum to meters. So we know that the maximum is 2 centimeters. So you could do 2 divided by 100, and that gives you the conversion. Now, straight away, you see in the viewport, we now have the full range of colors. Now we don't see blue because obviously blue is the tiniest ones. And if we change the particle, in fact, let's change it to 0.5, and let's do so basically the largest particle we can have is 1.5, and the smallest we can have is 0.5. So, 0.5 and 1.5. So to change that, we do 1.5 there, and then here we can do 0.05. And there we go. We can see our ranges are fixed, and we can see the blue now. Is that actually correct? Yes, 1. I didn't replay the simulation. So it's actually, can you see it's clipping? There's a lot more red than there should be. So if I press play again, there we go. Now we have the full range. It was biasing a lot towards the red, which means that we had loads of particles over the maximum value, over that maximum input. So we can see now that we've actually got a very specified range of particles, and we could actually go a bit further and have a much more defined range. We could say only particles. I mean, if we set them both to 1, we're not going to get any range at all. If we set that to 0 and that to 1, we're kind of clipping it, if you like. But really we want to use the real ranges, so let's do that. 0.05, there we go. And now if I play with the output values, you can see this is where we can kind of clamp it somewhere on this ramp here. So if I go to 0.5 and 0.5, we should be seeing only green, and that's right. So 0.5 is now exactly 50% on that gradient. Let's do 0.25. That's around about here, so it's that blue. In fact, I think if that's divisible, that should be, yeah. So if we go to 0.75, we're getting the exact yellow, and obviously 1 will give us the red. Now, obviously, that's not very cool. We want the range. So if I do 0.5, that means our smallest particles are going to be the green, and then our largest particles are going to be the red. Let's use it with a more interesting scenario. Using it with a ramp, that's very helpful, but there's actually a more... there's some nodes in cycles that actually really suit this particular workflow. So we're done with our formula, so let's move that off screen, and let's get something a bit more useful. And I'm going to use a blackbody node. Let's tidy up our node graph. We could just use this. If we jump here, we can actually auto-arrange those nodes, and they'll nicely sort of place themselves next to each other. I like to space them out a touch more, just so they're a bit more readable. Let's get rid of our color ramp. We don't want that anymore. And you can see now we just get black and white values from 0 to 1. That's cool. What if I get a blackbody node? Now this node, you might have seen this one before, but if I solo it out, this gives us a temperature range from 800 all the way up to 12,000. And this is a blackbody radiation sort of shader, maths node, input node. And what it does is it converts values or temperature values into a color. In real life, all objects have a sort of electromagnetic radiation depending on their temperature. So if you heat them up, they'll go through this range of colors, and really low temperature stuff tends to be, and by the way, this is in Kelvin, so 0 is minus 279 or 239, whatever, Celsius. All the way, and you'll be familiar with things like 6,500 Kelvin is like a neutral computer monitor, and that's like when it's at that lighting. If you're under a light that is 6,500 Kelvin, you'll get quite a natural color response in cameras and stuff like that. Anyway, back to the actual temperature thing. So the higher the temperature is, and temperature is, it goes through a different color shift, and that's called blackbody radiation. The lower they are, they go through the oranges and reds, and then the higher they are, which requires way more energy, it actually hits into the blue values. Now, it doesn't look very blue here, but if I connect that up to our emission, unsolo it, and I drop the strength down, you'll start to see that that is actually a blue, and especially if I go up to the highest value. But the reason it goes to white is that it's a really high temperature, so the power is higher. Let's get it 5,000, 2,000, 1,000. But say I wanted sparks. Say I want high energy sparks, particularly useful for things like fireworks. And let's let's attach our range mapper to this. Let's make sure our strength is on 1. And currently, the problem is that we are inputting 0 to 1 as our outputting 0 to 1 as our range. So we've got our particle radii of 0.5 centimeters to 1.5 centimeters, but they're being mapped to a maximum range of 0 to 1. Now the blackbody node is expecting a range of 800 to 12,000. So let's change our output minimums to 800 and then 12,000. And now we're going to get the full range of blackbody radiation temperatures. And you can see it biases hugely towards the blue. So there are more blue and white colors than there are the reds. And that's because in blackbody radiation, the range of energies to get to blue is huge. So from 6,000 to 12,000 is a huge energy jump. And also and those are the blues and whites. What if we just wanted it to look more realistic, like on Earth temperatures, if you like? So say it sparks from a fire where they're only going to be reaching sort of a few thousand degrees. So if I do 4,000, and you're starting to see we're getting a nice range. And we also, the thing here is that we're actually seeing this dark red, but at that dark red level, we're actually getting a really low power. So what that would be is, what that would mean is it wouldn't be very visible to the naked eye. And we can actually use our range mapping node to drive our emission strength to simulate that as well. We'll do that in a second, but I just wanted to show if we clamp the ranges a bit more tightly around sort of the 3,000, 12,000 ranges, you get this nice warm color there. And if we pump the emission value up, you see we get that nice hot glowing color and a nice realistic warmth to it. Excellent. So let's, I was going to add some geometry and compare these, but I'll do that in a minute, and we'll work with the age again. But for this one, oh, I've duplicated that one. I didn't mean to do that. I had two selected by accident there. So I've just duplicated our range mapping node, and let's just connect that. And then with this one, I'm going to just do 0 to 1. And what that's going to do is that if our particles are tiny, or sorry, the smallest value they can be, they will have 0 values output. And then if they're the 0.15 radius, they'll have the full value. Now, if I connect that to our emission, you'll see now we start to get the strength in there as well. And we could pump that emission value. So we could say 10, 5 or 10, but the smaller ones will always kind of go to a full black. If I added 1 in here, you'll see that it actually brings back some of these much darker particles. Let's zoom into one of the tiny ones. So if you see these are dark at the moment. If I increase it to 1 to match it to 5, that makes no difference. Oh, sorry, it matches them all to that brightness value. Okay, so hopefully you're starting to see the power of this and the way you can kind of control. It's like color correcting, but for input values. You're taking them, you're remapping them. You know, you can do this with curves and all sorts of other things, but this I find really, really useful on all types of different mapping all types of different inputs with particles. Okay, so let's call this one blackbody. Let's duplicate it because I'm going to want the range mapping nodes. And I'm going to use the color this time to remap. So I'm just going to delete this one. I don't want to map our emission just for now. I'm going to let's keep blackbody in here for a minute, and let's pump the color back in. And I need to change it. If you remember, I need to go back to 0 to 1. Now, one other thing is let's put this 0 to 1, 0 to 1, 0 to 1. What we can do is we can actually save this range mapping node. So if I duplicate this out here and I right click it, I can go save group. And you can see here, I'm in my preference folder, cycles 4D groups. And then you can just save it as whatever name you want. And I'm not going to call it rage mapper. That's, so what did I name it here? So range mapping. So range mapping, save. Now, if I unfilter that and I open this, that's now been added to our groups. And you'll see it's got all the name and the default stuff. If I jump in, it's exactly the same. I'll jump back out, and that's just going to be useful for when you now jump into a new scene and you need a range mapping node, you have it there to load. And groups and things, you'll have probably a few more of these if you've downloaded our preset ones, and they're incredibly useful, but making your own is also highly recommended. Okay, so we've got our range mapping. I need to delete that one. So we've got our range mapping. We're mapping our color from 0 to 1, and then our output is 0 to 1 into the black body. Let's change that back to, say, 1200, 4000. I didn't mean to default those. And let's call this one black body color. I guess, particle color. P color. And let's drag that onto our emitter. And you can see now it's taken our black value and to our white value and just mapped it along there. Now, to show you how powerful this workflow is, let me take some geometry. I'm just going to match the... it could be roughly matched. Oh, actually, no, let's just match it fully. So I think it's going to be 450 because we've played the particles for 3 seconds. I'm just trying to match the shape here. So we played the particles for 3 seconds. They were going 150 units by default. So over 3 seconds, it's 450 frames. 450 centimeters. Let's just make sure that's lined up nicely. It's going to be half of 450. You don't need to do this step. This is just purely to compare particle to make sure that we can have different inputs. So I'm going to duplicate this node here, and I'm going to jump into it, and I'm going to call this one gradient, and you'll see why in a second. So currently I've got particle info as my input. Let's attach that to our plane. Now, obviously a plane doesn't have any particle info, so it's actually useless. And it's just using our 0 value, which is down here, as the output. So I'm going to delete our particle info node, and I'm going to add a gradient texture. So in our input value, I'm going to put the color. Let me solo this out. That looks like it's worked, by the way. So if I solo that out, you can see our gradient texture. And let that go there. Now that looks like that is matching up. Let me increase the number of particles to 20,000. And that is looking like it is matching up perfectly. And so you can see we can not just use this for particles, but also geometry. And the beauty of that is that we could just take this range mapping group. We could drive these parameters perhaps with Espresso and just have them, you know, emitting on a surface based on these colors, these ranges, all that kind of stuff. So my point here is that you don't just have to use this on particles. You could use it on hair as well. Let's just do that for fun. Let's just definitely don't have to follow this bit of the tutorial. I'm going to pause our render there. I'm going to go add hair. Oh, let's let it play a bit of dynamics. I do love the hair object in Cinema. It's fun. If I press play now, we're going to have nothing interesting happening. But let's duplicate our blackbody gradient and let's call it blackbody hair. And let's add a curve tag to our hair and throw this material at the end. And you can see something interesting is happening. Now the gradient is just going from one side of the object to the other, so that's not what we want. What if we wanted the gradient to run down the hairs? You'll see what I'm doing here. So if I grab a hair info node, and I grab this, if I solo this intercept layer, you'll see it's a black to white gradient from the base to the tip. So I'm going to add that to the input value, and there we go. We've actually got, let's go back to our, there we go. You can see our core is that color, and we can change our ranges, of course, to say 0 to that 12,000, and we'll get the full range of brightness color on the hair. Okay, so this is starting to hopefully make sense to you that the range mapper is awesome and very useful in so many scenarios. Let's delete our hair. I think we don't need that for our scene for now. Let's play to the end. I've given you sort of the idea of range mapping with the blackbody, but there's also another really nice node called the wavelength node. So let's do the same thing. I'll do it on the particles to start with. So I'm going to duplicate our blackbody and I'm going to change it to wavelength. Now that'd be nice if I put wavelength in and it did all my work for me, but we don't unfortunately have that advantage. I'm going to drag that onto our emitter. I'm going to, instead of having this blackbody node, I'm actually going to go for a wavelength node. So I go to wavelength, throw my wavelength in. Now this, if I solo this out, this gives us a value from 380 to 780. And what that is that's a wavelength of light. And it converts that into a color that we can use in cycles. So you can see down here, blues tend to be at the 400 levels, so 400, 500. If we go too far that way, we end up in this really deep like violet, basically. And if you go further left, which we can't because that's not on the visible spectrum, that would be ultraviolet. Wavelengths towards the 500s are going to be the greens. So that's nice there. And then up towards this end, around about 600, we're going to hit the reds. Now it does go further and we get to the infrareds because there's a much smoother fall off from 600 to sort of 780. But we can obviously dictate those values from our range mapping group. So let's delete our blackbody, unsolo our wavelength, and attach it. Now, we're seeing nothing. Why is that? Well, that's because our output minimum and maximums are way too high. So they're currently 1200 to 400. We know that the wavelength takes a value. If I disconnect it again, if I go to the minimum value, it's 380. The maximum value is 780. We don't have to stick to those. That's just a guide. So I'm going to say 380 in the minimum, 780 in the maximum. And straight away you're seeing we get the electromagnetic spectrum. And that's awesome because we can now take slices of this and grab very accurate colors or ranges of colors in that part of the spectrum. And now if I just take this little setup that we've created here and I jump into, let's say, we had a gradient one, didn't we? So duplicate our blackbody gradient, rename it wavelength. gradient, delete those, and jump in here. And now if I paste this in, I copied it from the other one, I just delete those. It's not going to connect us multiple up, so just connect these up here and there. And oh, we need to assign it. And there we go. We get the matched up gradients. Now you can see there's a little bit of a shift here. And that's probably because, if you recall, I was saying the input needs to be a linear gradient. So it might be that. So if I jump into our emitter, our display, and I change this to a linear gradient, we probably will see a match. And there you go. So that's just something to watch out for when you're doing range mapping and working with gradients and stuff like that, in C4D especially. Okay, so hopefully that's helped you understand how to create a range mapping node and a range mapping group, and hopefully you can use it in your projects. We're definitely using it in a lot of the tutorials, so I will reference this training video whenever I do. If not, we will provide this .cyg file that you can just install yourself, and it'll all be ready to go in this groups section here. So there we go. Just drag it in and then connect it up, and happy range mapping.